Hello friends, let us now learn some important points about tube rating charts. So this is a tube rating chart. Okay. Actually, if you see the load for an X-ray tube is mainly measured as kilovoltage peak, milliamperes and exposure time. So we have a unit which is called as heat unit. Heat unit is an artificial system. According to the heat unit, so what is heat unit? Heat unit is actually product of the current into voltage, peak voltage into exposure time will give the heat unit. Heat unit, if you see for a single phase, for a see normally we have single phase generator and we have a triple phase generator. Triple phase generator is also called as constant potential generator. According to the single phase generator, heat unit is equal to milliamperes into kilo voltage peak into exposure time. Okay. Now we have kilo voltage peak and average velocity. Kilo voltage peak and average velocity are not same in single phase generator. In single phase generator, kilo voltage peak is equal to 1.4 times the average voltage. Whereas in triple phase or constant potential generator, kilo voltage peak is equal to average voltage. Okay. In single phase generator, we will get the kilo voltage peak. So as a result, heat unit is equal to HU is equal to milliamperes into kVp into time. Whereas in triple phase or constant potential, heat unit is equal to milliamperes into 1.4 into kVp into time. This is for heat units for triple phase or constant potential. This is heat unit. Similarly, this is artificial system. Then we have one more system which is called as SI unit. In SI unit, power is defined as watt. Watt is equal to 1 ampere into 1 voltage, which is equal to 1 milliampere into 1 kilo voltage peak. Because 1 ampere is equal to 1000 milliamperes and 1 voltage is 1 kVp, kilo voltage peak is equal to 1000 volts. So if you substitute 1 ampere is equal to 1000 milliamperes into 1 voltage is equal to kVp by 1000, then we get 1 watt has 1 milliamperes into 1 kilo voltage peak. Then the work or unit of energy or work in SI unit is joule. Joule is equal to watt into second, we'll get joule. So joule is an energy. Similarly, heat unit is also energy. Right? Now, what is the joule for? So if you see the joule, so based on this joule, if you see the energy, again we can divide it into single phase and triple phase generators. First, triple phase generator or constant potential. Actually, here the in constant potential for joule we have milliampere into voltage into time. Exposure time will give us joule. So for triple voltage for triple phase or constant potential, voltage is equal to kVp. So for constant potential, joule is equal to kVp into milliampere into time. Whereas in single phase, for single phase, if you remember, kVp is equal to, sorry, for average voltage. So for single phase, if you multiply average voltage, sorry, if you multiply average voltage with 1.4, we'll get kVp. So for single phase, joules is equal to, here we are using average voltage. So kVp by average voltage, that is kVp by 1.4 into milliamperes, that is current into time. So these are the two different things that you have to learn for joules and heat units. Then the next important thing that we have to learn is about the X-ray tube rating chart. So what is this X-ray tube rating chart? Why is it necessary? So we have an X-ray tube, right? We are doing this X-ray tube with the anode and also the cathode. Okay. Now, one thing that is important is that for this X-ray tube, to the amount of heat that is accepted by the X-ray tube without causing damage to the X-ray tube is determined by few important things. It is determined by the type of the rectification, type of the power supply, surface of the tungsten anode, and also the length of the exposure. Then there are three important characteristics that you should see, that you should make sure while using the X-ray tube. That is the ability of this tube to withstand high temperature. The tube should be made in such a way that it can withstand high temperature, it can withstand rapid exposures like in angiography, or it can withstand multiple exposures during hours of severe usage, heavy usage. So we have to see the safety limit for an X-ray tube. The safety limit for an X-ray tube is mainly operated by tube rating chart. So we have a chart which is called as tube rating chart. So this is a tube rating chart which was given in Christensen's physics. So according to this tube rating chart, this will determine the amount of exposure for mainly the single exposure. This is mainly for single exposure. Based on this, we can also derive from multiple exposures also. So just imagine that, for example, if we require an exposure of 50 milliampere second, okay, so what does this mean? That means if we require 500 milliamperes in 1 second, okay, 500 milliamperes in 1 second, in 0.1 second, sorry. 3 milliampere second is 500 milliamperes in 0.1 second. At that time, we need to operate at 70 kilowatts pressure. So maximum limit for this 500 milliamperes current with 0.1 second is 70. In order to obtain 500 milliamperes of tube current in 0.1 second, we require a voltage of 70 kilovoltage peak. This is peak voltage. The voltage should be less than 70 kilovoltage peak. So this tube rating charts are mainly for single phase power supply, not for multiple phase or multiple exposures. Or is mainly for single phase power supply, not for three phases. For three phase power supply, there will be different voltage chart, but this is for single phase power supply. Then there are some certain procedures which require multiple exposures for a short period of time. See, we require multiple exposures during a short period of time. Whenever there is multiple exposures during a short period of time, this will produce lots and lots of heat energy. So, there are certain aspects or considerations which should be kept in mind when a tube is subjected to multiple exposures. 1. Surface of this target anode can be overheated by repeated exposures. Number 2. The entire anode, meaning in the present day we have this entire anode assembly with anode stem and induction motor. All of this might get overheated by repeated assembly. Before the heat from the anode may be dissipated into the oil and also the tube housing, before this whole goes into the tube housing itself, the entire anode may be overheated. Then, on repeated exposure, not just anode. At first, maybe the anode is overheated. Later, this heat might go into the induction motor and complete anode assembly. Later, the heat might go into the oil and also this tube housing also. So, with series of exposures, the whole anode along with the X-ray tube might be exposed to higher heat conditions. So, we have to calculate the upper limit or at least the safety limit of using the X-ray tube. So, for repeated exposures like for angiography also, for that also, we can use this X-ray tube charting. So, how can we use this X-ray tube charting? So, first we will have to see for single exposure. We have to calculate the amount of voltage needed for single exposure or amount of heat units needed for single exposure. If you see for single exposure, the heat units which are generated, here I am keeping 500 milliamperes in 0.1 second. Obviously, we require 70 kVp. Okay. Now, if you see the heat units, we know heat units is equal to MA plus K into kVp into time into 1.4. That means almost we are getting 500 into 70 into 0.1 into 1.4. Overall, we'll get some 5000. This is for single exposure. Now, if you have to think that there is 10 exposures. For one exposure, if it produces 5000, then for 10 exposures, it will produce obviously 50,000 heat units. This is according to our this mathematics. Then what about from the chart? From the chart, if we have to calculate for 10 seconds, okay, let us calculate. It's same. Heat units is equal to 70 into, this is for 10 seconds at 70 kilovoltage. This will produce something here. Okay, almost 150 milliamperes current. Okay, 150 milliamperes current and time is 10 seconds. And again into 1.4, which is conversion factor. This will result in 15600 U. Sorry, 1,56,000 heat units are obtained. Here the input is almost 50,000. 50,000 is obviously less when compared to 1,56,000. So obviously we can use this this method. Okay. So this is how we calculate the safety limit for multiple, for 10 seconds, because 10 seconds at 70 kilovoltage peak is almost will generate a tube current of 1.150. So as a result, I used 150. It's almost 1,56,000. So with the help of this X-ray tube rating chart, we can calculate the amount of heat units which can be obtained and what is the upper limit of usage. Then we have one more charts which are called as angiographic rating charts. According to this angiographic rating charts are also available Here, for example, if we assume 20 exposures are done at around 2 exposures per second. So we have 20 exposures at 2 exposures per second, which is almost generates 8,800 joules per exposure. So meaning 8,800 joules per exposure is generated. So when there is per exposure 8,800 joules, that means a for total amount of heat, total amount of energy that is generated total amount of energy is equal to 20 exposures, and each exposure generates 8,800. That means 1,76,000 joules of energy is generated in the whole system. So this is the thing. This with using this angiographic chart, we can understand how much heat it can generate. That is for 220 exposures. At 2 exposures, it can generate 1,76,000. The joules of energy is generated. Now, the ability of X-ray tube to withstand this heat loading over the several hours depend upon the anode heat storage characteristics. There is something called as anode heat storage characteristics. So let us see that. So this is the chart which is explaining about anode heat storage characteristics. According to this anode heat storage characteristics, we have, for example, if we have to see that 1,10,000 joules of energy is maximum. So for cooling a anode with this 1,10,000 joules of energy, it will require at least 7 seconds. So actually heat loss by radiation is directly proportional to the fourth power of temperature. So if you give a 500 joules per second heat input continuously, if you give a 500 joules per this chart, 500 joules per second is given continuously, it can reach a maximum of around 1,10,000. Following by which, in order to cool this 1,10,000 joules of energy, we need to at least stop the system for 7 seconds. Sorry, 7 minutes. We'll have to stop the system for at least 7 minutes. Okay, but if we are going to use a small amount, that is if we are going to use only 340 units of energy. If you are going to use 500 joules per second, then within 7 minutes, 1,10,000 joules is reached, and in order to cool this 1,10,000 joules to almost decreased values, we need 7 minutes. We need to stop the system for 7 minutes. But if we are going to use lesser units of around 340 joules per second only, here the graph has been plateaued. So we can use this system indefinitely for longer time. So this concept is used in fluoroscopy. In fluoroscopy, where we have to take multiple images very fast, very simultaneously, we use less amount of energy of only 340 units per second, so that we can use this amount of energy for production of X-rays. At the same time, we do not need to stop the system for 7 minutes, because by the time we stop the system, because fluoroscopy is used in operation and in other applications where we need repeated exposures and rapid exposures of X-rays. So for cooling the system, we need to allow the X-ray tube to dissipate heat and to cool down, so that the X-ray tube will not break down. So this is about the anode storage capacity and tube rating charts. Thank you.